It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmer Junior Nice Coffee.
Hi guys, here's another one of my videos for you to hopefully help you with doing some basic things in chemistry. This one today is going to be all about balancing equations. So I suggest that you go through and you do the video and have a look at writing formulae first if you struggle with that, because the key to getting balanced equations correct and getting full marks is writing the formulae correctly. That's the first thing. If you get the formula wrong, it's going to be really hard to balance and you're going to waste a lot of time. So start learning those formulae, learn how to write them effectively, and then we can jump into balancing equations. So I'm going to go through these 6 steps, alright, which if you follow every time for balancing an equation, you'll pretty much never go wrong. So firstly, write all your reactants and products. Now sometimes you only get given the reactants, so you need to work out what the products are, and we can look at that in some later videos, but write them down, okay? Then balance the metal atoms first. That's always the easiest thing to do, okay? Generally there's only one set of metal atoms, sometimes there might be 2, but just look at balancing them, they tend to balance up really nicely. Then balance any non-carbon, hydrogen, oxygen atoms. So what I mean by that are things like phosphorus, sulfur, chlorine, even nitrogen sometimes. Balance those, try and balance them before you go on any further. Now sometimes you'll find polyatomic ions in there, and I talked about those in the last videos. That's things like phosphate, PO4, 3-, nitrate, NO3-, okay? Sometimes it's best to not try and balance up those P's and N's, but sometimes by balancing them you'll actually help later on. Then you go to your carbon atoms, okay? Do those, and then balance oxygen and hydrogen. Now depending upon which one you're doing, do the one that there's least of. So if one side's got 3 oxygens and only 1 hydrogen atom on that side, try and balance the hydrogen. It's going to make it a lot more simple. On the reverse, if it's got 4 different species have hydrogens and only 1 have oxygen, try and balance that first. But leave those to the end, and sometimes they will balance out by using water, which makes it really nice. So we're going to start off with just some simple chemical equations to begin with. So I'm just going to start off with the reaction of sodium with water. Okay, so we've got sodium atoms. Okay, it's sodium metal. When you put that into water, you get quite an exciting exothermic reaction. It fizzes around. Sometimes you get some flames, and what you'll get is some sodium oxide. Okay, and hydrogen gas. It's the hydrogen gas there that provides all the energy for the flames as it combusts in air. So let's have a look at this equation. All right. And sometimes what you can do, it's kind of helpful to have over on the side a little table that you can use, alright, where we write down the atoms. So we show left hand side, right hand side, okay, and then you actually put down the list of the atoms and you go through it. So we've got sodiums, we've got hydrogens, we've got oxygens, alright, and they're the same on that side as well. So you actually go through and have a look on this side. We've got 1 sodium, we've got 2 hydrogens. Remember, any number down the bottom here relates to the element before it, or the atom before it, alright? And we've got 1 oxygen here. Over on the right hand side, so separated by the arrow, we've got 2 sodiums, we've got 1 oxygen, and we've got 2 hydrogens. Okay? So straight away, hopefully by doing up this table, you'll be able to see what doesn't match. And you can see quite simply here, it's the sodiums that don't match up, everything else does. Okay? So for this, it's actually pretty straightforward. Anytime you're balancing, you must always put numbers out the front. Okay? You never change any of the subscript numbers. You always put numbers out the front of any of them. Okay? Golden rule. So for this one, we want to get that to be 2, so we need to multiply it by 2. Right? So that is what we put out the front of the sodium over here. Okay? And that balances our equation. Because the hydrogens and the oxygens already match. So that's pretty straightforward. And you might find it helpful to begin with to do these tables over on the side. What I always suggest you do is you write your equation in pen and then start doing your balancing in pencil, because sometimes you might need to rub one out, okay? And so it's much easier if it's in pencil before you go on to the final one. So let's have a look at something that's a little bit more involved, okay? So let's do an acid-base reaction. So we're going to take sulfuric acid here. Okay, we're going to react that with a base, so let's choose calcium carbonate, and this gives us 3 products. We get calcium sulfate, okay, we get water, and everything else through there. I'll show you with oxygens in a minute. So there's 2 hydrogens. We've got 1 sulfur, 4 oxygens here, and there's another 3 oxygens over here. So that actually gives us 7 oxygens in total. We've got 1 calcium, 1 carbon atom. Okay. Then you come to the right hand side. We've got 1 calcium, 1 sulfur. We've got 4 oxygens here, plus another 1 here is 5, plus another 2 there gives us 7. All right. We've got 2 hydrogens here, and our carbons we've got 1. All right. Straight away, hopefully what you notice is that all your numbers match. Now, always double check that you haven't missed anything. But when you've got that, all the numbers match, okay, you go, beauty, I'm done, you leave the equation just like that, okay? That's why getting your formulae is so important, because if we got any one of those wrongs, we could have spent hours trying to balance it up, it probably wouldn't have worked, all right, and we would have got frustrated. So it's really important to make sure you get your formulae right. So, look at another one here. Alright, let's do a combustion reaction this time, because sometimes these can be a little tricky, and I'll show you a little shortcut you can use which makes things a lot easier. So I'm going to take hexane. Hexane's a liquid, alright, and if we burn that in here, alright, what we'll get is carbon dioxide and water. Anytime you go through complete combustion, you always get carbon dioxide and water as your products. So, what you can start to do once you start to get a little bit more comfortable with this is start to follow through these rules that I showed you, and you might not have to go through and do that whole process of the table, but sometimes when you're getting started that can be really helpful. So what we're going to do is I'm actually going to follow this time, okay? So what I'm going to do is I'm going to balance the metal atoms first. So if I have a look, there's no metal atoms here. We've only got carbons, hydrogens and oxygens. So I can actually jump down to step 4, which is balancing our carbon atoms. Okay? So I look here, and I'm going to do this in red to hopefully make it a little bit easier for you. So we've got 6 carbons here. So I'm going to put 6 out the front of the carbon dioxide over here. Right, to start balancing up. Then I'm going to go to the final step, which is balancing your oxygen and hydrogen atoms. Now remember what I said, the best thing to do is look at what you've got the least amount of and start to balance that. So here we've got one thing that's got hydrogen, one thing that's got oxygen. Over here we've got 2 species that have oxygen in it. Okay? So I would leave the oxygens to the end and just try and balance up the hydrogens firstly. So we've got 14 hydrogens here, we've got 2 here. So what we want to do is try and make these equal. So what do we do to 2 to get it to 14? Well, we need a 7 in there, don't we? Alright, so if we put a 7 in there, 2 7s are 14, that's our number that goes out the front there. So we end up with 7 water molecules at the end. So all we've got to do now is go through and balance the oxygens. Pretty simple, right? So we've got 6 oxygens here times 2, so that gives us a total of 12 oxygens there. And we've got 7 oxygens there. Okay, so 12 plus 7 gives us a total of 19 oxygens. Now the problem we've got is that over here, we've only got 2. 2 and 19 are not nice numbers, okay? Because they don't divide. When you've got odds and evens, alright, it makes balancing a little bit more complicated. However, what you can do, which is perfectly fine with the SACE board, is write fractions, okay? So if you actually use these 2 numbers, 19 and 2, 19 over 2 times 2 gives you 19, which is exactly the same number you had over this side. So it actually helps you to balance up completely. So what you can do is leave your equation like that, okay? With a fraction in there, you get full marks because it's properly balanced. And when we're doing sort of combustion reactions like this, we actually like to leave the number out front here just as a 1 without changing all around, and you find you save yourself a lot of time. So hopefully that just helps you through, alright, doing some balancing of equations. Again, there's no substitute for just practicing them, okay? Try and do as many as you can, try and balance them up, okay? Last time I'm actually going to show you is what we do when we've got charged species in the reaction. Spectator ions. So I'm going to start with some sodium chloride, and we're going to react that with some silver nitrate solution, okay? And what we're going to get here is some sodium nitrate and our silver chloride, okay? Now, we often quite like looking at this reaction. Now, if you have a look at this silver, so sodium chloride is a colourless clear solution, silver nitrate is generally tends to be a colourless clear solution as well. When we're reacting together though, we get this very strong solid white milky precipitate, which is actually silver chloride. Okay? And that's what we're really interested in the reaction. Now that's actually balanced as it is. It's a really nice simple equation. But what you'll sometimes see is what we call an ionic equation, where we show that the silver ions, Ag+, okay, react with chlorine ions, alright, Cl-, okay, to give us silver chloride. Alright, and sometimes you might see the states actually written. So that means that aqueous, they're dissolved in water, and they react to give us a solid precipitate. Okay. Now notice a couple of things in these ones. Okay. Number one, the atoms balance. Okay. So we've got one silver here, one silver here. And secondly, the charge balances. Okay. We've got a 1 plus here and a 1 plus here. Sorry, 1 plus and a 1 minus. That gives us overall a negative charge on the left-hand side. On this side, we've got no charge. So we've got no charge, no charge. They balance as well. Okay. So sometimes you might need to write them, but what you'll find is if you balance the atoms properly, the charges will balance as well. Okay. That's until we get to redox equations, which is the topic of the next video. Thanks, guys. Practice. Hope this helps.